No, no. For part 7, we're going to be talking about containerization. And yes, next slide. So containerization is a technology that pretty much bundles up all dependencies and libraries and all environment variables into one single executable file, right? So for instance, let's say right, he's using Python and he only codes in Python and I only code in Java, right? Java has a JDK, that's an environment and all that. I can package up my Java code into a container and he'll be able to use my Java code and run it on his machine without even setting up any JDK or any environment necessary. So yeah, and it's pretty lightweight too. Here, next slide. So there are some benefits to this, like since everything is bundled up into a independent container, it doesn't need to interact with anything outside the container. So isolation, that's a plus, and it's pretty consistent too. Like if it works on my machine, it'll work on every other machine, meaning that if the container, what's inside the container will run on my machine and it works perfectly, I could put all the things that it needs into a little box and ship it out to all the machines that I needed to run on. So, and it takes up less space, so that's why it's more efficient. So, yeah, good on that? Yeah. Okay, next slide. And there's a bunch of uses for it. The microservice architecture versus monolithic architecture, right? So containers are mostly used in microservice, but that's more expensive. And so what microservices are is that it's a bunch of containers interacting with each other. And that's pretty much a microservice architecture. It's everything has a separate server that it interacts with. So it's very cloud-based and it's different from a monolithic type of system where a monolithic development or architecture, it uses one big server and it pretty much does everything. It's monolithic. If you're starting like a little startup, it's pretty cheap. So that's the one benefit of a monolithic architecture. You can kind of control everything and yeah, it's pretty cheap. So this is something to keep in mind, I guess. And oh yeah, continuous integration and continuous development. CI/CD pipeline. So what that is all it is that it's just a bunch of containers interacting with each other. And that's why it's used. So yeah, oh, and it's easily deployable. Like I said, it's very lightweight, so it doesn't take much to deploy. It doesn't take much data to deploy. Safety. Oh, so every container is independent and it's self-contained. So if let's say a container blows up, if something doesn't work right, you could easily replace that singular container with a different one that's the same thing, but it works. Does that make sense? Yeah. So it's easier to deal with in a large group setting. Because if we're all messing with like, let's say 100+ containers and one blows up, well, it's pretty easy to replace. Just take it out, put a new one in. Easy, simple. And with the monolithic one, you're gonna have to look at like thousands of lines of code to find a bug. So yeah, monolithic architecture, I like to compare it to like, what is it called? A single kitchen restaurant, you know? Something catches on fire, the whole restaurant has to close down before operations can go on. So, yeah. Next slide. Oh, yeah, and here's monolithic versus a microservice architecture. As you can see, the monolithic is very simple. This has one database where everything controls everything, that does everything. It's pretty cheap, very simple too. And the microservice down here, all these microservices, you can think of them as like containers in and of itself. Like a microservice deals with one specific function of one specific task, and that's all it does. It's very modular in a sense. So, yeah, and it has 4 different other databases to, mess around with. So, yeah. Oh. Virtual machines versus containers. So a VM, you probably used it in like assembly. Virtual machines are very, very hefty to use. Because one, let's say you're using a Mac, right? And you're trying to do something on Windows. That's like having one operating system, which is Mac, on top of another. So that can get really expensive, and like it's gonna pretty much cut your RAM into half. It's gonna be super slow. So that's why it's like not really wanted if you're trying to like work on something in Windows on a Mac. What you can do is use a container. A container is lightweight, it doesn't eat up as much. You don't need another operating system to run a container. It works with the kernel. And what a kernel is it's pretty much like, it's pretty much the link between hardware and software in your system. Very lightweight. Everything you need is in that container. So, yeah. Does that make sense? Oh, and
I'm trying to grasp the difference between the kernel and how the virtual machines do it.
okay. So a kernel, you can think of that as like the link between hardware and software. So that's like bits and binaries, zeros.
That's what the container is interacting with?
Yeah. Am I correct about that?
The container, instead of interacting with the kernel, it uses the container engine. Like right here, we have the containers don't say interact directly with the hypervisor or the operating system. It needs the container engine to interact it.
Yeah, so what a hypervisor is it's pretty much like a database that holds operating systems. That's all it is. Don't worry about it. It's kind of virtual machines. Oh, and so what you can use to make containers is, well, Docker. That's probably the most famous one. Amazon has their thing. I think they call it containerization services, but it's pretty much the same thing. So Docker, it's a platform for developing, shipping, and running applications in containers. So to dumb it down, it's pretty much like a cloud-based service where you can package up your code, ship it to the cloud, and my friend Iger, if he wants to pull my code down, he can pull it from Docker. That's pretty much what it is. It's pretty much a containerization system. And what you need to know is that it needs a Docker image. So an image is like, it's a blueprint of how the code is going to run inside the container. So it's an instruction manual pretty much, or a recipe. And that image will run the code in the container. Make sense? Good? Cool. Next. Here we go. Container orchestration. So when you're building like a microservice architecture, right, it's going to scale up really quick, and dealing with 100 containers at once, it's probably not feasible. So you're probably gonna have to like figure out a way how to automate certain things like updates or deployment of containers, right? So that's where container orchestration comes in, and there's tools for this too, like Kubernetes. Yeah, okay. Kubernetes, and Amazon has their things too. Amazon. And what all they do is that it pretty much helps automate deployment and deletion of certain containers, right? If there's like 5 people on your service, right, and you're capped out at 5, you're gonna need to deploy more containers to hold more people. So you can automate it with container orchestration. And there's also like self-healing, right? When there's a faulty container, there's a faulty service, microservice. The program like Kubernetes, it would automatically discard that faulty container and put a new one in. Right, and updates and rollbacks, that gets into CI/CD. Right, let's say you're updating your service. Right, you can work on the update in your local computer, right, and push the update onto the cloud, and that'll automatically take off the outdated container and put the new one in. Does that make sense? Yeah. Okay. I could have probably made an animation, but I don't know. So you're working on your update on your local machine, right? You're trying to update your web service, right? It has an old container in it, right? You're gonna pretty much do the little Indiana Jones thing where like he replaces like, you know what I'm talking about? Yeah, that's pretty much what you're doing, if that makes sense. Yeah. So we're all good on that? Cool. And yeah, there's some tools for container orchestration. Kubernetes, that's probably the biggest one if you're dealing with like a lot of containers. AWS has a bunch of services, but well, it's not great, so yeah. Fargate, it automates containers and deals with CI/CD pipelines, like I said before, the updates and all that. AWS Lambda, it's event-driven programming. So what that means is that it will react to different changes in the environment. So like if more people are like going on your website, hey, deploy more containers. If less people are, hey, take out some containers. It's dynamic. Keep it dynamic. It's cool that way. And that's the list. I just put the ones that I thought were really cool. Yeah. So if you could see right here, Elastic Container Services, ECS, that's pretty much Amazon's version of Docker. Kubernetes services, that's like Kubernetes, but Amazon. There's all these cool things that deal with containers. Lambda, that's pretty cool. Cloud Map, that's also pretty cool. Yeah, so you can find all the information on AWS or on their website right here. I put it in the slide. All right, Iker is going to give y'all a introduction into Docker and how to use it.
So I'm going to start with the introduction with Docker. Like Dewey said, it packages and runs the applications in a loosely isolated container. It allows you to manage the infrastructure the same way as you manage your application. I wanna first explain how it works. It has a client-server architecture where the Docker client, us, interact with the Docker daemon. So the Docker daemon is the engine that manages all the Docker objects. This means images, containers, networking, volumes. The Docker client is just the command line interface where we pass the commands that we want to execute. these two components are installed in your host machine. But there are cases in which you have to connect a Docker client to a Docker daemon that is on a server outside of your machine. We have Docker registries. That's where we put the images, so other people can can push the images. The default is the Docker Hub. Is here where we find any kind of image that we want. They are organized into repositories. So if you want to push an image, you first need to create a repo for the image. And there are other registries such as Amazon Elastic Container Service, ECR, Google Container Registry. The Docker Desktop is an easy application to install for any kind of a computer. I would recommend you to install this. It has an GUI, so you can manage all your images, your volumes, your containers. It includes the Docker daemon, the Docker client, the Docker compose. So the Docker image, like Dewey said, it's just a template, just the recipe to configure the container that you want to run. It includes all the files, the environment variables, the binaries, the libraries to run the container. We're gonna use the Docker file to build images. There are two important principles for images. First, they are immutable. So once we create the image, we are not allowed to modify the image. We have to recreate it again. The other is composed of layers. Each layer is kind of like a modification of the previous layer. They are stacked on top of each other, like here. And the last layer is the one that is writable. Yeah. So every Docker file has to start with the base image. We can also specify the version. They are not case sensitive, but uppercase is for convention. So it's very used uppercase. So we have to, it's better for other developers to understand the code. We have the run command. That's the main way that we create images. We have environment. We can set environment variables. We can set working directory. This is where all the commands are going to be executed. We can expose ports in case the container has to interact with the outside world. Arguments that are easy to modify. So there are two ways that a command is going to be executed when we start the container. We have the CMD that is easy to override. We just have to pass arguments when we run the container, but the entry point is hard to override. We have to consider this when a container has to start with the same command. So Docker containers, we already know that is a very isolated process that has your application. We can create, stop, or delete containers. I'm gonna show you how to do it. One key feature that Docker has is that when a container is removed, the data is not stored. So you have to use persistent storage, like volumes.
Like what?
Volumes. We have the life cycle of a container. First, we create the container, or we can also run directly the container. We can pause the container. We can stop and delete the container. Here's some of the commands. I'm gonna show how to create images and run the containers. So I create just a simple web page with Flask. It's going to get input from the user. And yeah, it's going to use the port 8080. That's important because we want to expose the port of the container with the port of the local machine that I'm using. So like I said, we have to start with the base image. In this case, it's Python with the version 3 right here. We can override this argument if we want to. So one of the best practices is that we first install all the dependencies and then copy all the app that I want to run.
Is this an extension you need to install?
No. You only have to install Docker.
Oh, yeah.
Docker has a command line interface where you can run containers and create images.
This is the setup file, so when you run
Yeah,
the Docker,
this-
the
this is a-
instructions, build file.
This is the Docker file. We have the Docker, we set up the working directory where we are going to execute the next commands. Yeah, so now I'm gonna create this image. We're gonna pass a Docker build command and the path where the Docker file is. So right now I'm now in the directory that the Docker file is. So I have to pass. Yeah. So we check with the Docker image ls. We see that we have some images. I forgot to tag the image. So the tag of the image is just the name of the image that you want to give it. Docker image, Docker build. And you pass the T command, the T option to name the image. Workshop. You can also put the version of your image. I put one. The path. we check the Docker images. See right here that we had the Docker image that we created. I might change to the directory that I have.
It's going.
Because I haven't created, yeah, I haven't created another, I haven't changed it, I haven't modified the image. If I modify the image, it's going to create another one. That's all the image that I have in this computer. So what I want to do now is to create a container with the use of this image. So I'm gonna press Docker run. We have to port map the container ports with my computer, with the ports of my computer. So 8080, 8080. The first port is for my computer, and the second port is the port of the container. And we also have to specify the name of the image. We see now there you go. If you want to stop the containers, we can just press Ctrl+C, but I'm gonna start using the command line. Docker stop and the name of the container. But we don't know, we didn't give it a name to the container, so we have to find out first the name. If you want to see the list of the containers that are running, just pass the command docker ps, and we find it right here. So docker start and the name of the container. It's going to stop the container. Yes, so you want to remove the container, docker remove and the name of the container. With the docker yes, and the option A is going to list all the containers that we have, even though if it's not running. So we can see that we don't have that container that we just removed. What else? So the first, this command just run the container directly. But if you want just to create a container, but without running it, you have to pass the command docker start all the options that you want. In this case, we want the port mapping. And we're gonna give it a name. Name. PowerShell container. Name. Also, if you want to remove the container once it terminates, you can pass the flag RM of the option RM to remove the container automatically. Yeah.
How did it get a name before when you didn't specify?
It's just random. random.
That name, pedantic, whatever was a random name?
Yeah.
Huh.
Yeah. So now we pass the Docker file, the Docker image name. Worship image. And Docker. Okay. I see. It's Docker create, sorry. Instead of Docker start because we don't have the container yet, so we have to create it. Docker create. Again. And yeah, we have the idea of the container. If we do Docker ps all, Docker ps all, we see that we have the container that we just created. The status is just created. If you want use the GUI is better for visualizing the names of the containers, the ports. If you want to start the container, just Docker start. Okay, start. You can attach the container to your command line, but if you don't pass the attach flag, it's just gonna run the container in the background. Docker start and the name of the container. Container. Yeah, it's running on the background. Docker. Yes. We have right here. You just have to pass the command Docker start. If you want to attach the container with your command line and see the logs, you have to pass the A flag. I'm gonna show you how. First, I'm gonna stop the container. I think it's gonna delete the container too because we pressed the flag. Yeah, we passed the RM flag, the RM option. So yeah, we have to create the container again. Okay, create. But in this case, I'm not going to pass the RM flag. I'll pass the flag the ports. The name. Okay. Sure. Right.
So like right there.
Sorry. Thank you. And we're gonna pass the image, the name of the image for sure. So now I'm gonna start the container, but I wanna attach it to my console, to my computer. Docker start on the option A and the name of the container. Workshop. So you see that now we can see the logs. Okay, here. Yep. What else?
It's a -8 for?
Attach. To attach the container to your console.
When you just had Docker
Uh,
Okay, so when it runs in the background, you couldn't pull it up on the page?
yeah,
You have to, so you have to attach, Docker is its own thing, it's a cloud thing. So that flag -A, it connects the cloud to your local host, which is the console. That's the web page. So that's the idea of it.
another,
When you put it in the background, does it still attach it to your local?
No, it's running. That just means it's running. So you're gonna have to manually attach it.
another command. Let's suppose that you have the container running, and you forgot to pass the attach flag. You have the Docker attach that's going to attach your console to the container and the name of the container. For sure. Container. Yeah, we see the logs, but let me just load right here. What else? I think that's it for running Docker processes. Yeah.
When you attach it, it just attaches to your local.
Yeah. So I should have probably been more clear about this. It's Docker is cloud-based. That's partially why it's like super lightweight, because everything that it's computing is all in the cloud. And
You have to buy
yeah,
it.
yeah, yeah.
Otherwise, it's just gonna be running in the cloud.
It's just gonna be floating, yeah, yeah.
So now I'm gonna push the image. I'm gonna show you how to push the image. First, you have to create a repo in Docker Hub. Docker Hub.
It's GitHub.
No, Docker Hub. Create new repo. You wanna name it whatever you want. The namespace is going to be your user or the organization name that you're working on. Create. Every time you push images, you have to tag the image as the same as your repo. Yes. Docker images. Plus I'm gonna modify the image. I'm gonna change the tag and do Docker image, Docker build with the tag. There's going to be the namespace. The namespace of your repo. In this case, my username. And then the name of your repo. You can specify the volume, the versions of your image. And press on the path. Okay. Check the images. We see it right here. Before you push the image, you have to log in on your Docker account. If you install Docker Desktop, it's going to ask you for signing, and automatically it's going to sign in your CLI, your command line interface. So I am already using my user. So I just push the image, Docker push. I think the name of your image is speakers. I forgot the tag, but it's going to, if you forget the tag, it's going to be latest. The tag is going to be latest. So let's where it is. Next, I'm gonna talk about Docker Compose, that is running multi-containers environment in the same host. It's not Kubernetes. Kubernetes is more like more complex. Docker Compose is kind of like a small scale. I don't know why it's taking so long to be honest.
Questions? Yeah.
Question about those three different images you have. Like, what's the difference between them? They all have the same ID.
The tag. Yeah, the tag. Just the tag. You can have the same image with the same tag with different tags. Yeah, we have it right here. So if you want to pull an image, you just pass the Docker pull and the name of the image. And in this case, Iker Santana, but in this case, I already have it on my local computer, so it's not happening. It's not gonna have anything. Yeah. Docker Compose is a tool for running multi-container applications. Like I said, it's simple. We're gonna make use of a YAML configuration file. This is known as the compose file. You can also name it as the Docker compose file. Just a configuration file. It's very basic. I'm gonna show you how.
It's like a Docker file, but on steroids. In simple terms.
The compose application have different levels. We have the service level. That's where kind of like abstraction for the containers, where we configure all the containers. We have the networks. That is kind of like a space where the containers communicate with each other. So we want two containers to communicate with each other. We have to put them in the same network. Volumes that are persistent data. So we can define volumes. We also configs, the configs level. That is just configuration for the data on the runtime or platform. And the secrets that are kind of like more specific configuration that is data that is sensitive, for data that is sensitive. We have, I'm just gonna talk about the service level. We have the build keyword that is going to look for the Docker file that you said that you want to, that the container should run on. And the container name is obviously going to give a name to the container. It depends on control the order of the service. So if you want to a service to start first, or you want to service to start before another service, you can set it up by the depends on keyword. Environment files, you can set up environments outside of your Docker Compose file. If not, you want to make use of environments that is in the Docker Compose. Images to specify the image. Networks, like I said, you have to set up the containers that are talking to each other in the same network. The ports is the same as the P flag that I was using when we create the containers, when we start the container. And the restart in case of the one of the service doesn't start completely or fails, it's going to restart every time that it depends on the policy, to be honest. We have the no, so we have the no policy that is not going to restart. That's the default. That's the default. We have the always that is going to restart always, like it's going to retry every time. On failure, in case of the service having a start. On the unless stop. Here the commands we are going to use for the Docker Compose. The Docker Compose app is going to start all the services. The down is going to stop and remove the services, the logs. We can check the logs of the compose. Docker Compose PS is going to list the services. So I have this. It's the same application, web application, in which we are going to take the input of the user, and we are going to save it on a database. I'm gonna use MySQL. Here's the YAML file. So we pass the name of the project that we want to, or you can just exclude the name of the project if you want. The service level and the network level. In the service level, we have two different services. We have the app and the database. This is a container. This is going to be another container. In the app, we pass the build keywords to specify where the Docker file, where the compose file is going to look for the Docker file. We have right here the compose file, so it's going to look for this in this container for the Docker file. That depends on it's going to wait for the service to start, but here's the problem. The app is not going to wait for the database to be initialized. So we're gonna face some problems, but I resolve it with the restart always. So it's going to retry every time. It's going to retry after it fails. The ports, I do the port mapping. In the database, I put some environment variables required for the database to initialize. Yeah, I'm using the MySQL image, the networks. These two services have to communicate with each other, so they have to use the same network. Yeah, that's right. So again, you have to be in the repo where your Docker Compose is. Docker, sorry, let me see. Let's see. Docker Compose. Up, it's going to start the services. It's not working. Like I said, we're gonna face some bugs because the database is not ready for connections. Once the database is ready for connections, we get these logs from the app that is ready to run. Okay. Localhost. I'm gonna pass some data. We see that we get these logs from the app service. So now I'm wanna check that the data was saved on the database. So okay, I'm gonna check the processes that are running. Docker, yes. You have we have the database container and we have the app container. So I'm gonna use the MySQL image I'm gonna use it as a client. So Docker run, I'm gonna pass the RM flag. Also, I forgot. So oh yeah, the IT flag that is going to allow us to interact with the container with the container through the command line network. And we're gonna pass the network that these two containers are using. Database expect networks. Copy this. I'm gonna pass the the image that I want to. In this case, I'm gonna use MySQL. SQL. The command. So we're gonna start by MySQL. The host name that is going to be the name of the service. In this case, DB. The username. In this case, going to be user. Finally, the password. And now we are running another container that is going to be the client right here. Yes. We have the app databases. We're gonna use that. Use. Routine. User. Users or user? Yeah, we have right here the input that we just passed. I'm gonna pass another input. Oh, I didn't expect that, to be honest. It was running like 2 hours before, right? Yeah, I think that's it for. Oh, it's duplicating. Sorry. There you go. Yeah, there you go. I think that's it for the compose. Does anyone have any question?
Does anyone have any questions about Docker or containerization? I have one question, maybe start a set of questions. How might you see containerization and Docker as being useful for our, capstone project? How might we use that for, the project that we're gonna be working on this semester?
So
I feel like
for-
for the development stage, we can. There are Raspberry Pis images on Docker Hub. I was thinking about that. So we can create an image with all the libraries that we need, using the base image of Raspberry Pis and also Python. And I'm not sure how we are gonna use Docker when in the deployment
you-
statement. Right.
So I think Raspberry Pis, I think they use some form of Linux. So what we can do is we can find a Ubuntu image and upload that onto Docker, make a container, and then we can deploy it like that.
We might have to use Raspberry and not Ubuntu, depending on what the leap motion, because
Yeah,
since Raspberry Pis run on an ARM processor, you might have Raspbian and specific,
yeah.
drivers for the leap motion. I think Pod 5 is looking into that, and we looked at both doing Ubuntu and Raspbian, and Raspbian was the Raspbian. Yeah, so you'll have to find a Raspbian image, but is everyone kind of clear on that? Like, one of the really powerful advantages of containerization and Docker is allows us to kind of have like an OOP design philosophy for our environmental workspace. Like, as you develop your code, you might be working on a Mac, you might be working on Windows, you could be working on any other kind of machine, but really you're trying to replicate an environment that is a Raspberry Pi, right? Your code doesn't do any good if you're developing it on a Mac and doesn't run on a Raspberry Pi, right? So this allows everyone to be developing on effectively virtual Raspberry Pis with all the libraries and modules across all teams to guarantee that your code will be able to deploy and run in the environment you expect it to. And allows everyone to use the same modules and the same libraries locally on your own machine, whether it's a Mac or Windows, whatnot, but working in an environment that replicates the Raspberry Pi environment. So just like Git allows you to go ahead and kind of share code between teams, Docker kind of allows you to share environments across team members as well. And it helps you standardize your environments. Is there any other questions? Oh, just you were asking about YAML files a little bit earlier. Just to be a little bit more specific, YAML file is a human readable, usually configuration file. Outside of just being used by Docker, it's used by other build tools as well. But the big thing about it is its use case is to pass usually configuration information to an application, so it knows how to boot the application up. And so some build tools will use YAML files, some will use JSON files. So it's a different type of human modifiable file that allows you to configure your application before you launch it.
GitHub action that is
And can you show the YAML file? If you look at it, it's usually a key value pair. So it's not dissimilar to how you might think of as like a JSON file, but the syntax is different.
Yeah. I think GitHub.
Application uses which.
So, I mean, you will have to know, like, so when you're learning how to use an application and it requires initial configuration, you'll have to know if the configuration files in the format of a YAML file or a JSON file or an XML file. That's another file format that's human readable and is used to pass configuration information for an application. And any of those, it depends on whoever the developer is on how they want to have you configure the application to launch. So some applications will require an XML, some will require a YAML, some will require a JSON file. But it's good to kind of encounter all these different formats, so it's not foreign when you look at it. And so then you're just like, oh, this is how I set up the launching of this application, so it'll create the container that I need. Yeah, can you go back to your YAML file that you had? Yeah, you see it's key value pair. And then once you understand that, then it becomes very easy to read. Yeah, I have another question. How might you safeguard secrets in a Docker file? Because we're gonna have all sorts of secret information that we're not gonna want to make public, right? Things like API keys or passwords.
I think you have to create a file, and I don't know where, to be honest, it's located. Let me see, please. Right here. That's where you gonna locate your all the secrets that you want to. You're gonna access them in Docker Compose. You're gonna access them by secrets. The name of the secrets that you want, whatever name. Not a big secret. I think 5. You put the path or your file, where the file is.
And everyone can see like the value of this, right? Like we don't ever want to push
Yeah, you didn't have.
sensitive information on GitHub or anything like that. No API keys, no passwords or admin level
You don't want to hard code
access.
this.
Like it's silly, but usually in a junior dev role, that happens all the time. And then, of course, there'll be lots of people who will scan GitHub looking for keywords like password.
Yeah, I think that's it. Does anyone have any question? Yeah.
No, all right, cool.
Excellent. Oh, I'll do one last question. What's going to be the deliverable for this particular project?
Oh, make a Docker image. Yeah. Simple.